welcome to Oxpoon, the technology magazine. Hello and welcome. Today I would like to talk to you about radiation and radiation meters. Radiation surrounds us everywhere and always. For example, visible light. That means the light that we can see with our eyes. If we leave the range of visible light, the frequency range, in the direction of more energy-intensive radiation, we enter the range of UV radiation. And we already know from common knowledge that UV radiation can be harmful if the dosage is too high. If we then go a little further, we are in the area of X-rays. X-rays are something that we generate with an emitter, which is generated to serve as a lamp for a different frequency range, for a frequency range that we cannot see. From there, which is a smooth transition, we enter the energy range, the frequency range, of radioactive decay, and there we are initially in the gamma radiation range. I say that this is a flowing range, which means that the energy of X-rays and gamma radiation merge into one another. But radioactive decay, radioactivity, is not something that we generate with a lamp. It is a nuclear physical process. These are nuclei that emit photons. So that would be the case with gamma radiation, or beta radiation, which is even more energy intensive. Electrons or positrons are emitted. In other words, the nucleus, the atom that emits this radiation, becomes less energetic, smaller, because it shoots this energy wildly into the environment, you could say. And then we have the alpha radiation, which is even more energy intensive and sends a whole helium-4 atom into the environment. So the nucleus shrinks, the number of elements decreases, and a complete atom sets off, shoots into the environment. And we can probably already see from this very figurative, very brief summary what can make the whole thing dangerous. Because it is ionizing radiation. It is radiation that is so strong that when it hits objects, including our human body, for example, it can cause effects. It can make changes there, and those changes can also cause damage. And that is why this radiation is dangerous. The pitfall is that we have no sensory perception of this type of radiation. We don't feel it. And what we don't feel must be detected by other means. And for this, we need test equipment that can do this. And these measuring devices, which are among the oldest measuring instruments that we have for this, include this device that was used by the German armed forces, for example, and also in civil defense, the FH-40T. And as you can see, if we look at the display here and wait a bit, then due to the natural radioactivity that surrounds us all, as I said earlier, this device deflects from time to time, as you can see up here in the display. And we also have the option of setting different modes. The switch is on the side, and what I want to show you is up here. If you look into the slots there, we can say we only want to measure the gamma radiation. And if I go back again, beta radiation, gamma radiation together, and only gamma radiation, there is suddenly a shielding over here, which is because the gamma radiation can penetrate this shielding. But beta radiation cannot, or only to a very small extent. And so you can distinguish between these two types of rays. So, if we go back here, I can show you the same thing again in the display. So we can change to different scales, or here, you can see beta and gamma detection. And if I switch further, then we only see the gamma radiation here. How does this device do that? Well, it has a so-called Geiger-Müller counter tube built in. And if I take this counter tube out of its holder up here, it has to be unscrewed here. Then I can pull it out here. So here is the holder for the whole thing. And if I take this off here, then we have this tube. And we see here two sides where a voltage is applied. And in this tube, here in the middle, there are noble gases. And whenever radiation hits this noble gas, It generates a current pulse, and that is the pulse that we have seen here on the display. Very primitive, very old-fashioned, the way it used to be done many, many decades ago. Of course, these old devices only have an analog display. They have no memory or no interface at all, no digital interface to the computer. Technology has developed further in this area as in many others. For example, with a device like this. This is a hobby device, I have to say. It's not something that should be used professionally, but as a hobby, for understanding, perhaps also for children, to make it comprehensible. It's reasonable to use this. This device can already display mean values. For example, we can see down here how the radiation changes. We hear that characteristic click that we know from movies and television when it comes to radioactivity. And we now see a value here that we can read off, namely in microsieverts per hour. This is the SI unit for the power dose of radioactive radiation. So this is the unit that is established in this area. And that is roughly the natural background radiation that we have. As I said, since this device should not be taken completely seriously, the radiation here shows a little more than it should. In German-speaking countries, we have very different background radiation from north to south. The part that comes from the cosmos, the cosmic background radiation, is of course relatively evenly distributed. But there are also elements in the soil. The soil is of course made up of normal chemical elements, and there are also some that are radioactive, radon for example. And these elements are unevenly distributed. We have less radioactivity in northern Germany, while it increases towards the south. And above all in the low mountain ranges such as the Ore Mountains, the Black Forest and the Bavarian Forest, we have an increased concentration there. And even higher in the Swiss Alps. There, we have 0.25 microsieverts per hour. So that's roughly what this device wants to show us here. If I take a sample now, and of course it goes without saying that we can't carry out any major experiments with radioactive samples because that would be highly dangerous for our health. But there is, for example, the so-called incandescent mantle. I can hold it up here. What looks like an undersized tablecloth has a fabric made of metal oxides woven into it. If you hold this over a gas flame, it starts to glow. It is quite efficient and produces a relatively white light. This is how people used to help themselves in the past, when it was not yet commonplace to have constant access to electric light. This made it quite easy to produce relatively bright light. But this sample also contains thorium, at least incandescent mantles used to, and this sample does too. And thorium is an alpha emitter, and, in smaller quantities, also a beta and gamma emitter. And we can certainly use this as a harmless or relatively harmless sample. If we hold the device to this, and we observe the display or we simply hear the clicks, they become more frequent. The display indication jumps up. So this device reliably indicates that we should stay away from it if possible. Modern incandescent mantles for Petromax lamps that are still available today, such as those still used in the military, no longer contain thorium, so they are no longer radioactive. So now it's time to take a look at some professional radiation meters. I have brought the PCE-RDM 5 with me, a personal dosimeter. You can see how small it is compared to my hands. It is therefore a device that is suitable and intended to be carried with you at all times. There are groups of people who work in areas where they are exposed to high levels of radioactivity. In radiology, for example, there is an obligation under the Radiation Protection Ordinance to carry such personal dosimeters, and these devices accumulate, so they do not only show the current radiation around us, as in this case, but they also collect the radiation over a certain period of time. And if we take a closer look at the display here, on the one hand, I can switch over. I can see what my dose is. The red line at the bottom shows the dose that I have been exposed to over a certain period of time. For example, we can see at the top here that the time is running. That's 4 minutes at the moment, during which the device is measuring, during which the device is active. And we also have the option for the device to warn me. I can set values at which I receive an audible warning or a vibration warning. And we can also see that here at the top of the display. Here we have symbols that are currently crossed out. One is a speaker symbol, which I have activated. You've also heard it as an audible feedback. I can do exactly the same. We can hear that too, by activating the vibration message. And I have 2 different alarms that I can set here. One is the rate, meaning the current value. If the current radiation exposure is exceeded, the device warns me. And on the other hand, the dose. This is the accumulated dose, which is the total radiation I have been exposed to. If I have exceeded this, I also receive a warning. This is because it varies depending on how we come into contact with the radiation. Some people have to work for a long time at relatively low levels of radiation. Other people are exposed to very high levels of radiation in a short space of time. And this device with these settings, the PCE-RDM 5, takes all of this into account. Here we see the PCE-RDM 10, a radioactivity meter in a robust housing that fits well in the hand, with a built-in rechargeable battery, but above all with a bright and easy-to-read display. We can see the current rate in microsieverts per hour at a glance at the top. Below this, there is an average value of the radiation, and at the bottom, when we start a measurement, the accumulated radiation over this time. But above all, we also have a graph of the progression over time at the bottom. And I can demonstrate that this device works by taking my incandescent mantle with the thorium and holding it against the back of the device. It takes a moment and then we can see that the values rise at the bottom of the display, and the device also makes noise. It warns me of the radiation, which in this case is still harmless for short-term exposure. But it is radiation that is above the natural background radiation. And then the device says, "Please take a look at this. Something is not as it should be." So it does exactly what you would expect from this device. It has a built-in memory. So we have the option of calling up old measurements again. So we can go through the menu here and display these measurements. It also tells us how many data points have been saved. And overall it makes a very good impression. A measuring device for X-rays, gamma radiation and beta radiation for measurement ranges up to 99.99 microsieverts per hour. The PCE-RDM 10. I am holding the PCE-RAM 100 in my hands. This is an extremely high-quality radiation meter for alpha, beta, and gamma radiation, in a range from 0 to 1,500 microsieverts per hour. It has a resolution of 0.001 microsieverts per hour. It also has a second range, where it measures up to 9.9 sieverts with a slightly lower resolution. We can see a switch, a manual switch, at the top of this device. And if we look closely at it with the camera, we can see some letters. Here on one side, it measures beta and gamma radiation. Then I can switch it over here for beta, gamma, and alpha radiation, and over here for gamma radiation only. Now, how does that work? When we look at it here with the camera, we see different materials that shield the beam path accordingly. These shield the alpha radiation, or the alpha and beta radiation, which are easier to shield than the gamma radiation. And thus, it gives us the opportunity to find out more precisely what type of radiation we are dealing with. In other words, we are able to classify the radiation. If we take the device, look at the display, we see a very clear presentation. So here we can see the current, rate, and I can switch between them. We can see the maximum, minimum, and average values. I can also have everything displayed as a graph. And I also have the option of displaying the pulses, meaning the pulses that this device picks up. And if I hold my radioactive incandescent mantle up here as a sample, then we hear that the clicks are becoming more frequent. And on the other hand, we can also see how much the pulses skyrocket here. Whereas if I take it away again, the natural background radiation remains. The menu, for example, should also be emphasized. On the one hand, we have the option of changing units, switching the ticker we have heard on and off, defining alarms. But we also see a data logger as the second item, an internal data logger, that can record millions of measured values, and these measured values can then be transferred to the computer. We also have other settings, standard settings such as date, time, language, and display. And we can also calibrate the device. The built-in battery can be charged via USB-C, and overall, this device fits very well in the hand, so it's ideal for taking it with us wherever we need it. The PCE-RAM 100. Let's take another look at the three devices as an overview. Firstly, the PCE-RDM 5, a very small handy device that can be carried around any time, and which must also be carried in radiology, for example, in accordance with radiation protection regulations. A personal dosimeter that can display the current rate, but can also display the dose, and also warns us if we exceed the dose or rate. Let's move on to the PCE-RDM 10, a handy device with an easy-to-read display that can show the current value and the average value. That can record data, and which also gives us a graphical representation of the last measurements at the bottom. And finally, the PCE-RAM 100, a very special device which, on the one hand, gives us the opportunity to classify the radiation, to select which radiation we want to measure, and on the other hand, offers a wide measurement range, a very easy-to-read display that can measure and display the pulses. It has a graphic display, and, last but not least, it can also save the measurements so that we can evaluate them afterwards when we have the time. I didn't want to miss the opportunity to present these three devices to you. Have a nice day, see you next time, and goodbye.
Discover and order the latest measuring and test equipment now on www.pce-instruments.com.